Hello, we start here the second part of this topic focused in the main agents that control the coastal geomorphological dynamics. And these we mark are the main contents that now. Let's try. In most cases, the waves don't get perpendicular to the coast, but they do it at a certain angle as it appears in the photograph. In this case, there will be a turn in the direction of the waves. What we call wave refraction. This refraction occurs because there's a part of the wave coming into the area that feels the bottom before another and therefore at that moment slows its advance, which causes a part of the wave to move slower than the other, thus causing a twist. Now you can see in red that twist we're talking about. It is very possible in any case that the turn will not be fully completed, and that the wave breaks before placing perfectly perpendicular to the shore. I enclosed two videos. The first provides an explanation of some example and the second is a very visual example. The remaining space between the break line and the shore. It's what we know as the surf zone. And it's a key place to understand coastal processes. In this surf area, there is already displacement of mass of water, and not just movement as happened in deeper areas. Here in the surf zone is where the coastal currents are formed and operate. And on the shore is the swash area, which is the remaining space between maximum and minimum progress of the wave. Coastal currents play an essential role in coastal processes. There are two fundamental types, perpendicular to the coast, and the longitudinal ones. Regarding to perpendiculars, we can say that they occur in the opposite direction to the coast, i.e., returning waters towards the sea. There are two types of currents perpendicular to the coast. The first one is a non-concentrated return flow. The second one is when it is concentrated in a specific corridor or channel. The latter is known as rip current and can be uniquely dangerous to bathers. To know more about the rip current, I suggest you watch the following video. Longitudinal currents, as we have already said, occur in the surf zone, i.e., between the break line of the waves and the shore. It occurs only when the waves break at a certain angle to the shore. So when the wave breaks, they project a vector of energy parallel to the coast, which causes the longitudinal current. Its speed depends on the height of the wave and the angle with that break with respect to the shore. Although the velocity of this longitudinal current is small, of the order of 0.3 meters per second on average, its morphogenetic role is very high. This is because it can move a lot of sediment that previously it has been lifted from the bottom by the turbulence it provokes. The breaking wave, the diagram is shown how and where it is, gives the longitudinal current that drags sands. This diagram also shows a scroll in the swash zone. I refer to this area. This is not, in sense, strict a current but a zigzag displacement of the most gross materials. They only moves in this beach sector, and with this we end this presentation of the main agents that explain the geomorphological coastal dynamics.